In this lesson, we will create a simple movement script for our player. We ensure that the player cannot move out of the screen by using a hard-coded bound on the x-axis. And we are investigating how we can make this border dynamic so that it adapts to the screen resolution. Finally, we apply a solid color as the background of our game. And we expand our playing field by zooming out with the camera. Let's start this lesson. Now that we have placed the player in the right place, we can add the function to make it move left and right. We create a function called movePlayer. Since our player can only move left or right, we only need to create a float variable for the x-axis. We collect the horizontal user input using the input.GetAxis. Horizontal. We use the user input to move our player using transform.Translate. We covered this in detail in Lesson 3 in the beginner series. If this goes too fast, it is wise to review that lesson. And don't forget to call the function in the update method. Let's test if we can move our player. We managed to control the player. Only it is possible to move the player outside the screen. We need to put limits on how far you can move the player from left to right. Let's see in the Unity editor, where we should place the boundaries on the left and right. The limit is approximately 3.3 units. To return the cube to its origin, you can reset it. Let's use this limit of 3.3 units to build the limit into our movement script. We create a float variable called boundX and give it the value 3. Using an if statement, we test whether the player exceeds the bounds. We test whether the value of the transform.Position on x-axis is smaller or equal to the value of the boundX. Because we are testing the position on the left, the boundX variable is negative. Let's immediately comment that we are now creating the bound on the left. When the transform.Position of our player is smaller than or equal to the bound, we want to place the transform.Position on the bound. Here again the bound is negative, because we create the border on the left side. We do not change the transform.Position on the y-axis and z-axis, so they are equal to the transform.Position of the current location. The border on the right side is largely the same as the way we created the left side, so let's just copy this. Because we are now creating the boundary on the right side, the boundX variable is positive. And important, the transform.Position should not be greater than or equal to the value of the variable boundX. When we test this, it looks like we've got it done. We cannot move the player past the bounds on the left and right sides. But when we select a different screen resolution, then you see the problem when we hard-code the bound. The screen limit is not 3 when you select a different resolution, but the limit remains at 3.3. Instead of hard-coding the boundary in our script, we should make the boundary dynamic. To achieve this, we need to be able to get the width of the screen Quite coincidentally, when calculating the height of the screen, to determine the bottom of the screen, we also calculated the width. This makes it easy to determine the bounds. This is half the width of the screen to the left of the origin, and half the width of the screen to the right. In the start method, we give the boundX variable the value equal to half the width of the screen. Since we already use the boundX variable in the if statement, this should be enough to make this work. So after saving the script, we can test this in the editor. Only nothing happens. We can't move our player. What's going wrong here? A script is read from top to bottom. So what could have gone wrong in our script? When we look at our start method, first the value of the variable boundX is set equal to half the screen width. And then the get function in start position is called. We give the width variable a value in the get in start position function, so we don't have the order of the code in our start method correct. We need to call the get in start position function before assigning a value to the boundX variable. If we have the order correct, we can test this in the editor. Now we have made the boundX dynamic. The bounds are determined by the screen resolution we choose. As you can see, our code also works when we select a different screen resolution. Because the pivot point is in the middle of the player, it appears that half of the player shoots over the bound. We could increase the bound by half the player's width. We can get this value using the mesh renderer, but I actually don't think it's wrong this way. So I'll leave it as is. The last thing we're going to do in this lesson is change the background. We now see the earth and the sky. That's a nice background for a three-dimensional game, but not for a two-dimensional game. Meteors can of course threaten the earth during the day. But for the dramatic effect, I think a nighttime setting for our game is better. Let's change the skybox to a single dark color. We select the camera in the hierarchy. Then we select the drop-down menu where we see Skybox. In the drop-down menu we select solid color. Then we can change the background color. I choose a dark color but not completely black. An additional advantage for us now is that the contrast between the background and our player is greater, and therefore visibility is better. Let's test this in play mode. Now I also think that we need a slightly larger playing field. We can adjust the size of the camera to zoom out. I think a value of 10 is good for now. If we have dynamically coded everything correctly, the player and boundX should adjust accordingly. Thanks for watching. In the next lesson, we're going to make the meteors fall at random locations from the top of our screen. I hope to see you back in the next lesson. Please like and subscribe, so you'll get notified if a new video is uploaded. More people will get this video in their search result when they want to learn Unity game development.